Welcome back to the video everyone. In this video, we'll be discussing question 9 and question 10 of activity 1.3. Let's get started. Here we have question 9 with us. In the question 9, we are given a system of linear equation where we have two equations. And it is said to us that if the given system has unique solution, then k should not be equal to. So see, we have seen this multiple times that if we have two equations, two system with us. So let's say we have a1x1 plus a2x2 equal to c1, and we have b1x1 plus b2x2 equal to c2. Then if you want to get the unique solution, then a1 by b1 must not be equal to a2 by b2. In this case, you will get unique solution. So we will be using the same method here as well. We are given x minus 3x2 equal to 4 and 3x1 plus kx2 equal to minus 12. So we will say that 1 over 3 must not be equal to minus 3 over k. So from here, we can say that k must not be equal to minus 9. So, because in the question it was asked that k must not be equal to what? So, k must not be equal to minus 9 if you want to get the unique solution. So, that was the question 9. Moving on to the question 10, we have system 1 with us and system 2 with us. So, we are given two systems. And suppose there is another system of linear equation which is given by this. So, for some real values of m and n, we have to find the values of n minus m. So first thing that we will do here is find the values of x1 and x2. So if we take the system 1. In system 1, if we check the equation 2, in the equation 2 we have minus of x2 equal to 5. Just ignore the 0 that is written over here. So that gives us the value of x2 equal to minus 5. Now, using the value of x2 in equation 1, that is x1 plus 2x2 equal to minus 5. If you put the value of minus 5 over here, we get x1 plus 2 times of minus 5 is equal to minus 5. That means x1 minus 10 is equal to minus 5 and x1 is equal to positive 5, that is plus 5. So the value of x1 is 5, whereas the value of x2 is equal to minus 5. Now, similarly, let's solve the system 2 as well. So we'll solve it here only. So let's do it here. So in system 2, we have minus 2 times of x3 plus x4 equal to minus 5 and 3 times of x3 plus x4 is equal to 5. So our plan is to subtract both the equations. So if we subtract both the equations, we get minus of 5 times x3 equal to minus of 10. From here we get the value of x3 equal to 2, and if we put the value of x3 in any of the equation, let's say we're putting the value of x3 in the first equation where we have x4 is equal to 2 times of x3 minus 5. So we get 2 times of 2 minus 5. So the value of x4 that we got is minus 1. Now, the next task is to put the values of x1, x2, x3 and x4 in the given equations. So we know that the value of m is going to be 1 minus 2, that is minus 1 times x1 plus x3 plus 3 times of x2 plus x4. So first let's write the value of x1, x2, x3, x4. So the value of x1 is 5, x2 is minus 5. And similarly, the value of x3 is 2 and the value of x4 is minus 1. So if we put the values in the equation, we get m is equal to minus 1 times x1 plus x3 is going to be 5 plus 2, 7 plus 3 times of x2 plus x4. So x2 plus x4 is going to be minus 6. So it's minus 7 minus 18, that is minus of 25. Now let's solve for the n. The value of n is given as 3 times x1 plus x3 plus 0 times something, plus 0 times x2 plus x4. So maybe this could be ignored and we just have to do 3 times of x1 plus x3 is again 5 plus 2, that is 21. Yeah. So our task is to find the value of n minus m. Let's do that. So n minus m is going to be 21 minus of minus 25. That would be 46. So that is our answer. So in this video, we have completed activity 1.3. From next video, we'll be starting activity 1.4. Till then,